derivatives of a composite function. Okay, so here is to find the derivative of this composite function, we are going to make use of this chain rule. So chain rule is nothing but I take a function that is a f, which is a real value function, and which is a combination of a two function. I'll take that is v and u. It is a combination of a two function. F is a real value function and it is a combination of u and v. Now I'll take this u is with a variable x and I'll take another variable that as a t. Next, this function v will be with a variable t now. Then this is of v of t. So how to find such a combination of a function is you need to differentiate this with respect to x. I took this function as a variable t. Therefore, you need to differentiate t function with respect to x. Therefore, dt by dx you have to do it. So next what you do is, here is you need to find the derivative of this is nothing but dv by dt. So at the last you need to find the derivative of this composite function is nothing but df by the function it is with a variable x. Therefore, you are going to differentiate this function with respect to x. So now the resultant will be, it is a combination of two functions. This function will be with a x, but I took it that as a variable t. Hence, you need to differentiate t with respect to x. Next, this is a t means this function will be with a variable t. It's nothing but you need to differentiate this t function, that is v function with respect to t, is nothing but you need to take that is dt by dx into dv by dt. Now these two get cancelled, you will get dv by dx. Okay, so I'll just take one simple example and you will come to know how exactly this chain rule will be applied. Okay, so here is composite is nothing but what? It is a combination of two functions, and such a composite function we are going to apply a chain rule. So here I'll take find the derivative of, they'll ask a question like find the derivative of tan 2x plus 3. I'll take this one and this is an important one, repeated question. It's a 1 mark question. Now you can consider this is a composite. How you can say that this is a composite means this is a tan is there and you can consider this whole thing is a one variable because this is also a algebraic function. It's nothing but one trigonometric is there, one algebraic is there. It is a combination of two different functions, trigonometric and algebraic. Hence you need to consider this is a composite function. So how we can differentiate this, such a composite function is nothing but we will apply a chain rule as I said that. So now I'll just take this as a v, that is before that I'll take this is 2x plus 3 is nothing but this is u of, okay, it is with a variable x, therefore this is u of x. Now I'll take this whole thing as a t, this whole function as a t. Next is, if this whole function is a t means this will be a tan t, right? Therefore I take this is v function, it is with variable t, hence this is a tan t. Hope you understood this. Here two functions, tan and 2x plus 3. What I do is, this algebraic function I take it as a u, it is with variable x, therefore u of x is a 2x plus 3 and this is variable t I will take. It's nothing but this whole algebraic function is a t now. Remaining is what? Tan t it is. I take this tan t as a v of t. Now differentiate these two, where this I took it as a t, therefore differentiate t with respect to x, it is variable. Now as we know that while differentiating, if it is a sum of two terms, you need to differentiate both the terms separately. It's nothing but d by dx of 2x plus d by dx of 3. Is it clear? Now you need to differentiate this 2x with respect to x. So here is a constant is there. Along with the variable constant is there. You need to write the constant as it is. Derivative of x with respect to x, that will be a 1 plus derivative of a constant. Here constant is nothing but some real value number. So here there is no variable. In that case, derivative of such a constant is 0. Therefore, dt divided by dx. Hence we can write dt by dx, which is equal to 2. Okay. Now you need to differentiate this v with respect to t. Therefore, what I will write is dv divided by dt. This v you need to differentiate with a t variable because this tan function with a variable t. So tan derivative is secant square, variable is a t. So at the last, so this is nothing but the function. Now this function you need to differentiate with respect to x only. Hence we can write this as, you can write that is dv divided by dt into product you need to do it, and here is dt divided by dx. Now, so dv divided by dt is nothing but this secant square, and dt divided by dx is a 2, or else you can write df divided by dx, which is equal to 2 times secant square t. At the last, you can write the derivative value is in a variable t. Why? Because we are going to differentiate this function with respect to x is nothing but the resultant also should be in a variable x. So now I took the t is nothing but 2x plus 3, else you need to write 2 secant square 2x plus 3. Okay, this is what the derivative of a given composite function. This is what the chain rule. Okay, just for a knowledge, I explained this chain rule, but in this concept they will ask you for 1 mark question. So I'll explain you the alternate method, which is a direct. Within a 2-step you need to write. Okay, so that is alternate is. Here is the 2 function, right? Tan and algebraic. What you will do is, first you need to differentiate this. So outside bracket you just differentiate. Once you differentiate that, you need to write the variable within this bracket. There is nothing but a derivative of a tan is nothing but secant square. For a secant square, you need to write the variable x, right? Instead of writing a x variable, you need to write this inner function as it is, that is 2x plus 3. Once you differentiate this function, again you need to differentiate this inner function without fail. Okay, so it's nothing but d by dx of 2x plus 3. Is it clear? Now you just write secant square 2x plus 3 and differentiate that. So as I said that it is the sum of 2 terms. You need to differentiate both the terms separately. It's nothing but dx by dx of 2x plus d by dx of a constant 3. So which is secant square 2x plus 3. So as I said in the same problem while applying the chain rule. So 2x, 2 is a constant, x derivative is 1 and the derivative of the constant is 0. Hence we can write this is 2 into 1 is 2, 2 plus 0 is a 2 only. Write the constant first. Therefore 2 secant square 2x plus 3. Both the answer is the same, but this is a chain rule and this is the alternate method, which is a direct method. So from this concept, they'll ask you a compulsory 1 question and it is for a 1 mark. So in that case, don't go with the chain rule. That is just for a knowledge, okay? And you need to write like this only. And if you know this one, a derivative of a sum of 2 terms, you can write it directly and you could have write in a 2-step only. because it is a 1 mark question only. So try to write it within a 2 or a 3 step. Is it clear? So I will do few more examples. And one more thing is, in an exam they will not mention it, find the derivative of a function by using a chain rule. They will not mention it like that. Okay, so in that case you can go with the alternate. If you feel that chain rule is easy, you can go with that, or else you can go with the alternate method. So now find the derivative of sine of x square. Okay, the sine is a one function, trigonometric. X square is an algebraic. In case if it is only a sine x, it is a one complete function. It is not a composite. If the variable x is with a power more than 1, then you can consider this is a one function and this is the another. Now it is a combination of two functions, algebraic and a trigonometric. Hence you can consider this is a composite function. So now I just go with the alternate. I will not use the chain rule. Clear? So now, as I said that, first you need to differentiate the sine. Sine derivative is what? It is a cos. For this cos function, what you will write the variable? Inner function x square as it is. Again you need to differentiate. While differentiating, don't use a plus. It is a product. Okay? Differentiate this. So for that function, write the inner term. Next, differentiate this inner term. Is nothing but derivative of x square. Now cos x square. So with the help of a formula, that is d by dx of x power n, is nothing but n into x power n minus 1. So is nothing but the power will come to like a product and the power will be decreases. So is nothing but power is a 2, n is a 2, so 2 into x power 2 minus 1 is nothing but 1 it is. So write the algebraic term at the last, first only. Therefore, a derivative of this composite function is 2x into cos x square. Simple, no? Okay. Just go with the alternate method only, guys. So next I just take, if it is a 3 function, sine, then cos and x square. Sine, cos, x square, 3 functions it is. So now, once you differentiate this, for this function you need to consider these two as a variable. Okay. Next is product. Again differentiate cos. For a cos derivative, you need to write the inner term, that is x square. Again you need to differentiate x square. So if it is a combination of 2, then you need to differentiate inner function once. If the composite function is a 3, combination of a 3, then you need to differentiate twice. Okay. So here is derivative of a sine is cos. For a cos function, you need to write within bracket, that is cos x square. Okay. One step is finished. Now differentiate this. Is nothing but d by dx of cos x square. Okay. Next is, again you need to differentiate d by dx of x square. Clear? Differentiate this outer function, that is a sine, derivative is a cos. Write the inner function as a variable of this. Then d by dx of this inner function, because it is a 2 function is there. Again you need to differentiate this x square. Hope this is clear. So now, don't write cos into cos is cos square. Write it as it is, cos of x square. Next is, derivative of a cos is minus sine it is. So while writing you should be careful, and this is not like a 2 terms. It is a derivative of minus sine. It is like a product. So minus sine of x square. Next, derivative of x square is, which is 2x. write, if any negative is there means write it first, and if any constant or variable is there means write it first, then write the function at last. It's nothing but minus 2x I take. This minus and 2x I write first. Next remaining is cos of cos x square and sine x square. This is what the derivative of this composite function. Is it clear, guys? So now I'll just move on to the exercise. So in exercise also they did mention that you need to apply this chain rule. So they mention like find the derivative of the following. Okay. So which is exercise 5.2. Now in that first one, it is a sine of x squared plus 5. First one, find the derivative of sine of x squared plus 5. This is a trigonometric and this is the algebraic, right? So now I'll just go with the alternate. It's nothing but direct method. Derivative of a sine is cos. So inner function is x squared plus 5. Now what you do is differentiate this within a bracket function. It's nothing but x squared plus 5. Okay. Now the cos of x squared plus 5. Now this is sum of two terms. So differentiate both the terms separately is nothing but d by dx of x squared plus d by dx of 5. Don't confuse that. Composite function, while differentiating that, we will use your product. Why this is plus means I am differentiating this term, algebraic term. Here these two terms in between a plus is there. So I just make use of that. Okay. So now cos of x squared plus 5. Derivative of x squared is 2x. Derivative of a constant is 0. So write the variable and a constant first, then write the function. So here is the 2x into cos of x squared plus 5. If you are good enough in a derivative of this function, like an algebraic function, that is x squared means 2x, 5 is 0, then you could have write that is 2x into this cos of x squared plus 5. This step you could have write it in a second step only. You will get a full mark. That means usually they will ask this concept, it is only for a 1 mark. Okay. Try to write within a 2 step. So second mark is it's a cos of sine x. Cos of sine x. Cos is trigonometric, even the sine is also trigonometric. So what you do is now, so cos derivative is minus sine. You can't write that sine x. Then you can't differentiate this sine x again. So now, once you differentiate this outer function, so differentiate that. For that function, the variable you need to write within this bracket, that is the inner function, minus sine of sine x. Next, go with the derivative of the sine, which is d by dx of sine x. So we can write this as minus sine of sine x. Now the sine derivative is cos x. Clear? Third one is sine of ax plus b. One is a trigonometric, one is a linear equation. It is linear means it is an equation. In an equation, if the variable 4 is a 1, then such an equation is a linear. So now sine derivative is cos. For a cos function, what you will write the variable? That is the inner function ax plus b. Now you need to differentiate this inner function, that is ax plus b. Ax plus b. So now the cos of down separately. So ax derivative is only a. Why ma'am? This is a constant. You can write it the derivative is a 0. No. The constant is along with the variable x. We are differentiating this variable with respect to x only. Variable is there. Hence you can't write this constant as a 0. So therefore constant you need to write as it is, and the derivative of x is a 1. Now this is completely a constant because there is no variable x. Therefore this is a constant. Constant derivative is always 0. Therefore the derivative of this ax plus b is only a. Hence a into cos of ax plus b. This is what the derivative of this composite function. Okay. So next, fourth one. Secant of tan of root x. Okay. Secant is a trigonometric, tan is a trigonometric, and root x is a algebraic. So now we know the derivative of all the three functions. This is a composite. Differentiate secant first. For this derivative you need to write the variable as these two. Again differentiate tan. For a tan derivative you need to write the variable is this. Again differentiate root x. Okay. So now the secant derivative is secant x into tan x. But instead of the variable x we have this function. So secant x derivative is secant x into tan x. Therefore secant x is nothing but tan of root x. Next is tan of tan root x. This is only a derivative of the secant. Now d by dx of this tan of root x. Again you need to write a derivative of root x. Hope this is clear. Derivative of secant is secant x into tan x. In the place of a x, I should write this inner function, that is tan into root x. So tan of tan into root x. Again you need to differentiate this tan. Therefore d by dx of tan of root x into d by dx of root x. Now just write a secant of tan root x, then tan of tan root x, then tan derivative is secant square. So your variable is root x. Root x derivative is 1 divided by 2 root x. Now don't use your overbrain, that is don't cancel out this root x and the root x. Okay. So most of you guys will do such a silly thing. Don't do that. You can't cancel out this root x and the root x because this is with a function. You can't cancel out the variable like that. So hence we can write. So I'll just write a constant first. Therefore 1 divided by 2 root x into secant of tan root x, then tan of tan root x, and secant square root x. Hope this is understood. Okay. So I'll do the last one, which is fifth one. So in the fifth one we are going to apply the product rule. Okay. Hope you remember the product rule. So fifth one is, which is sine ax plus b divided by cos cx plus d. So here either you can go with the quotient rule. Quotient rule means u by v rule, or I can write this as sine of ax plus b. So remaining will be a 1 divided by cos of cx plus d. So I'll just go with the trigonometric ratios. So 1 by cos is nothing but secant, right? So I'll just write that is the secant cx plus d. Now these two are a complete function. Okay. So now you can go with the product rule. This is a one complete function. This is a one complete function. Now you can take it. This is a u and this is a v. So as we know that d by dx of u and a v, product rule or Leibniz rule we can say, is nothing but you need to keep it as nothing but a derivative of a u. Derivative, either you can denote it by d by dx or dash it is. So u dash, derivative of first function, and you need to keep it the second function as it is. You need to use a plus, then keep it the first function u, then differentiate the second function. Clear? So now u is nothing but sine, v is nothing but secant. Now the derivative of this one is, so sine derivative is a cos ax plus b, don't confuse, listen carefully, d by dx of ax plus b. You may get confused that. So here we need to differentiate only this. Why we need to differentiate again this one? Means this is a composite again, sine is there, algebraic is there. So you have to apply the composite for this. Sine derivative is a cos, inner term, derivative of this inner term. Okay, that is a u dash. Now you need to write the v. V is nothing but secant of cx plus d. This is only these two. Now should use a plus. U is nothing but sine of ax plus b, write as it is. Sine of ax plus b. Now you need to differentiate this b. So secant derivative is secant x into tan x. Clear? So here is secant x is nothing but again the inner function cx plus d. Secant x into tan x, it is a derivative of a secant. Therefore tan of cx plus d. Again you need to differentiate inner function cx plus d. Understood? This is only a one step for this. I just applied the product rule. Sine is nothing but cos, inner term, derivative of this because this is a composite. Write the second term as it is, plus first term as it is, derivative of a second. Second is nothing but secant is there. Secant derivative is secant x into tan x. So therefore secant x is nothing but this inner function, tan inner function. Again you need to apply the derivative for the inner function because this is a composite. It is right in the last step, that is, I'll write it here only. Cos of ax plus b, derivative of ax plus b is a constant 0, a is a constant, right, as it is because it is with the variable x. Therefore x derivative is a 1, hence the remaining is only a. Okay, next secant of cx plus d. Now plus, write sine as it is, sine of ax plus b, secant cx plus d, tan cx plus d. Now the derivative of this is, d is a constant 0, c is a constant, right, as it is. Why? Because it is with the variable x. X derivative is a 1. Therefore the derivative of cx plus d is only a c. So or else you can write the last step. So in between any variable or any constant is there means you should write that as a first. Therefore a into cos of ax plus b, then secant cx plus d, plus in this the constant is a c, therefore c into sine of ax plus b and secant cx plus d and tan of cx plus d. This is the derivative of the composite function. Hope you understood this. Okay, I did in exercise 5 problems. Remaining we'll do it in the next class. Okay.